Okay, so let's start a topic called Diffie-Hellman Key Exchange method, which is a very powerful technique that we use in cryptography to exchange secret key between two parties, user A and user B. So let's go through it. Let's go through the algorithm, and then we'll work out an example as well. So here's how the algorithm works. Okay, so let's say we have two users, and both of these users wants to exchange their symmetric key. Symmetric key means both of the both of the parties knows the key, and how would they exchange that key? So let's say we have two user. First user is Alice. Second user is Bob. What they will do, they will choose a common prime number. Let's call that Q, and after choosing Q, they will also choose something called a generator, which is alpha. That alpha generator means is primitive root, and we have learned how to find primitive root in my previous video. I'll put a link to it. uh, so what these primitive roots are, they are actually the generators which actually generates the entire sequence of that prime number that you have chosen. uh, we don't care about the order, but it will just regenerate that entire group up till p minus 1. Then the third thing it will do, you will also have a global parameter, which is going to be each party is going to select some integer value. Let's call that x of a, and this is actually going to be that private key that they're gonna keep it to themselves. Okay, after both parties does that, what they will do, they will compute something called ya. This is sort of like a temporary key. Ya is going to be, both parties will generate that key uh, with respect to whatever the private parameter, like for example Alice has chosen x of a while Bob has chosen x of b, and they will generate something called their temporary key. I'm just going to call it a temporary key. So that y of a is just nothing but alpha raised to x of a mod q. Bob will also do that. uh, y of b, which is alpha raised to x of b mod q. After both of these parties have computed that key, they will send the result, which we are calling it yb, to each to other party. So Bob is going to transmit that to Alice, and Alice is going to transmit that to Bob. That's what these arrows depict. And after that, after receiving YB, that temporary key that we are calling it YB, what Alice will do, she will raise that key to her private parameter and will take a mod of Q, and that would be that actual key. And Bob is also going to do the same thing, but after receiving Y of A, which is temporary key of Alice, Bob will take that key, raise it to X of B, its private parameter, and take a mod with Q, and that would be that key. Now, at the end of the video, I'll explain what that key is. Even though they look different, but it's going to be a key exchange, which is for symmetric key, like for example, AES. So both of these keys are exactly the same. I'll show you a small proof of that. Okay, so let's start a problem. So the first thing I need to do is just select Q. All right. So what I'm going to do, I just Google something, and I'm going to choose my prime number to be 23. And after Googling Q is equals to 23, which is a prime number, I have found that it has 10 primitive roots. So I'm going to choose one of them, which is the easiest one. One of the primitive root is 5. So I'm going to choose 5. Why? 5 and other primitive roots are the roots, numbers, which actually generates this entire sequence from 1 all the way up to p minus 1, which is up till 22 without repeating itself within that domain. Okay, once I do that, the second thing I need to do is let's do it for user A first. So let's do it for Alice. Okay, so user Alice. So 23 is the prime number, alpha is the generator. The next thing Alice will do, she will select something called x of A. That x of A, let's say okay, she has chosen to be, and this x of A, there is a condition to it too. X of A must be less than Q. All right, same thing, xb should be less than Q. All right, so let's choose some number, like let's choose 7. I have chosen 7. Now she's going to keep that to herself. What she will send to Bob is this. So what she's going to do, she's going to compute something called y of a, which is going to be alpha raised to x of a mod q. All right, so let's compute this value. Alpha is 5, x of a is 7, mod 23. Okay, so let me bring out my calculator now. So here's my calculator. So let's compute this value. All right, so she is computing something called, okay, so the calculator that I have, the way I do mod is this. I have this button where they have fractions on it. So I just simply click on this. I'll get these two values. And I'm going to type in 5 raised to 7. So I'm going to type 5 raised to 7. And on the bottom, on the denominator, I will type in my 23. All right, and then I'll hit equal. So I get an answer which is in a fraction, 78,125 divided by 23. When I look at this button, which is S to D, and on top of this button, you can see that there's a symbol for improper and proper fraction. So I want it in a proper fraction. So I will press Shift and I will just click on this button. So what do I get? I'll get it in a proper fraction. And this top answer, not the denominator part, this numerator part is 17. That 17 is actually my remainder, because in mod we are only interested in remainder. So this is 17. So my YA is actually 17. All right. Then let's do Bob's. So Bob will have the same global parameters, which is Q is equals to 23 and alpha is equals to 5. Let's say Bob has chosen his x of b, which is his private parameter, to be something called, let's say, 9. All right. So what Bob will do, Bob will also compute y of b, which is going to be alpha raised to x of b mod q. Okay, so let's just plug in the numbers. So 5, which is alpha, which is 5 raised to 9 mod q, which is, in our case, is going to be 23. All right, so I'm going to bring out my calculator. I'm going to do exactly the same thing. So this is going to be, so I'm going to go to my calculator. I'm going to raise this. I'm going to do 5. So this number is too big for it. Now, here's how am I going to do it. This number is too big for it. So I know 5 raised to 7, 5 raised to 7 mod 23 was what? Okay, let's do this. So 5 raised to 7. So I can break this down into this. 5 raised to 7. If I have the basis same, and if I'm multiplying, what do? I add powers. So I can rewrite this in terms of mod 23. Okay, this is a good step that I'm doing, guys. Okay, let me move this paper up so you can see this. Okay, so let's do this. So what do I know? 5 raised to 7 mod 23. I know 5 raised to 7 mod 23 would give me 17. So I'll still have 5 raised to 7 mod 23 would give me 17. So I can do this, mod 23. Because my calculator was unable to give me the answer, now I can do this. I can do 5 raised to 2. I know it's 25, so it's going to be 17 multiplied by 25 mod 23. So 5 raised to 2 is going to be 27. How do I get 17? I know what 5 raised to 7 mod 23 is, as I previously calculated. This is 17. So I'm going to replace this 5 raised to 17 mod 23 with 17. Then I have 5 raised to 2 left. So what I'm going to do, which is now it's a simple problem now, 17 multiply by 25 divided by 23. So 17 multiplied by 25 divided by 23. I get 425 over 23. I'm going to press Shift SD, and after pressing this, this is the numerator. As you can see, my denominator is exactly the same, so my numerator is my remainder. So this is 11. So this is that YB. All right. So YB is 11. So right here on this side of the page, let's calculate K. I know, according to my I of B, raised to X of A mod 17. This is going to be my K. Okay, let's look at it. So calculating secret K. All right. This is for Alice. That's why I'm doing it on this section, so you would know. Okay, so this is going to be K is equals to Y of B. So Alice will send this information to Bob, and this is what Alice is doing now. So this is Y of B, X raised to A mod Q. Okay, so what is my YB that I received from Bob? That is 11 raised to X of A. This is only known to Alice, which is 7 mod 23. Now I'm going to bring out my calculator, and I'm going to do exactly the same thing. I'm going to try to see if 11 raised to 7, if I can get answer. So I'm going to press this fraction button. 11 raised to 7 as per this 23. No, I'm getting something in this. So I'm going to break this down into a smaller problem, just like I did it here. I'm going to see, okay, what can I do? How can I get this? So I'm going to try this. I'm going to break this down. I'm going to try 11 raised to 5. However easier I can get it in my calculator, I can use this number. All right, so I'm going to try 11 raised to 5 mod 23. Okay, now I got the number, which is in a fraction form. So I'm going to click on this, shift this. This is 5. So what I'm going to do is this. This is what I'm going to do. My calculator was able to compute 11 raised to 5 mod 23 easily, just like the way I wanted. So I'm going to break this down into two things. I can rewrite this equation as this: 11 raised to 5 multiplied by 11 raised to 2. When bases are same and you're multiplying, you're adding power. This is exactly the same thing. Mod 23. What I just calculated, 11 raised to 5 mod 23 would give me a remainder of 5. All right, this is what I'm seeing. So I can easily replace 11 raised to 5 mod 3 with 5. So I got this to be 5 times 11 squared mod 23. Okay, so now let's do this. So this is 5. So I'm going to bring out my fraction. This is 5 multiplied by 11 raised to 2, which is 121. I don't need to write it, but I'm just writing it anyhow. So you can see that you can do it in your calculator. Then hit enter. I get 605 divided by 23. So I can just press shift and SD button, and I'll get a remainder of what? 7. So this whole thing, 5 multiplied by 11 raised to 2 mod 23, would give me a remainder of 7, as you can see it on the screen on my calculator. So this is the K. What just based on what she has received YB from Bob, she has calculated her secret key, which is going to be an actual key. Now let's do exactly the same thing for Bob. What Bob will do once he receives YA from Alice. So calculating secret key. All right. Now, exactly the same thing. Upon receiving YA, this is what Bob will do. This is what Bob will do. Bob will bring this equation out. It got y of A raised to x of B mod Q. All right, guys. Okay, what is y of A that Bob has received from Alice? That is 17. What is x of B? What is x of B? This is the Bob's private parameter. So these are the private parameters that Bob will not share with anyone. So 17 raised to 9 mod 23. All right, guys. Okay, so now let's bring out my calculator. I know definitely it will not work. Why? Because 17 is a huge number. 17 raised to 9 is going to be something really huge. All right. Let me just put it over here. I hope you can see it. Okay. So 17. So I'm going to bring my fraction in. How easily my calculator can break it down. This That's why I'm choosing this. This is what. Let's try 17 raised to. This is 9. Let's break this down into power of 3's. So 3 raised to 23. Yep. Let's try 17. Let's do this. 17 raised to 4 mod 23. Yes, I can do that. Let's try 17. I hope you're getting it what I'm trying to do. However easiest way I can get this answer to my calculator, this is the number I'm going to choose. No. So 17 raised to 4. So let's try 17 raised to 4 divided by 23 would give me, let's do shift and SD, would give me an 8. So I can break this down into this. I can rewrite this as this: 17 raised to 4, 17 raised to 4, then 17 mod 23. But I already know what is 17 raised to 423 is. The remainder is 8. So I can replace 17 raised to 4 mod 23, 17 raised to 4 mod 23 with 2 8s. So this is 8 times 8 times 17 mod 23. So basically we're using divide and conquer method. So we're splitting down a big problem into smaller problem and then adding them up. Okay, so now the problem is quite easier. I have 8 multiplied by 8 multiplied by 17 mod 23. So I'm going to plug in this value. So this is going to be 8. So these are the numbers that I'm plugging in. 8. So I'm going to bring out my fraction. 8 multiplied by 8 multiplied by 17 divided by 23. And this is nice. 1088 divided by 23. Simply shift this. I get 7. So now check this out, guys. Isn't that amazing? Look at the actual key, guys. Now this is the key point. Alice has done this. Send YA to Bob. Once upon receiving YA, Bob has calculated. Bob has calculated the key, secret key, which is this: YA raised to x of B mod Q. This is exactly the same thing. Now, once Bob has calculated YB, he has sent this to Alice, and Alice has computed using y of b x raised to a mod q and get exactly the same key. These are exactly the same keys. Same. But now, I don't know if you guys have observed this. Look at this. But the keys that when you look at, they don't look exactly the same, isn't it? I don't know. It's just a thought process. Think of it like this. I can rewrite this Now check this out. Once I rewrite this, what is YB, guys? YB is nothing but alpha raised to x of b. This is YB, x of a, mod q. What is, so look at this, k. What is YA? YA is alpha raised to x of a raised to x of b. Now, when you look at these keys with respect to this, aren't they exactly the same? Isn't that amazing? Now, check this out. Why we said it's a zero knowledge proof in the beginning. Both of the parties, zero knowledge proof means this: without telling each other their private parameter, they were able to calculate a secret key which they can use to start their communication. I hope you guys are getting it. This is really amazing. Zero knowledge proof means because they have, this is x of a is their own private parameter. X of b for Bob is a private parameter. But without actually telling each other what their private parameter is, they just send a solution called YA and YB. Based on that YA and YB, they have actually calculated a symmetric key which they can use to communicate. And you can see a small proof of that. So this is actually a proof of that, sort of like a proof of that, that these indeed, these keys, they look different. I tend to ask this question a lot, that these two keys looks different, but they are exactly the same once you plug in place of YB, alpha raised to x of b, alpha raised to x of a. Now when you look at it, these are exactly the same. So I hope you like this small video on Diffie-Hellman Key Exchange method. So don't forget to subscribe to my channel. And don't, if you have any question, leave it in a comment section.